Hi everybody and welcome. This is another video in my AWS tutorial series, and in this video we are going to learn how to use condition expressions in DynamoDB. Now, before we just jump into coding and seeing some real-world examples, let's learn about what conditional expressions are. A condition expression is an optional parameter that you can use on write-based operations. If you include a condition expression in your write operation, it's going to evaluate the condition expression first, and if that condition expression is true, it will then write. Otherwise, it will abort. This is useful for a lot of common patterns, such as ensuring uniqueness, validating certain business rules, and confirming existence. And by using a condition expression, you can reduce the number of trips that you need to make to the DynamoDB table, and you avoid race conditions that can occur, since reading from the DynamoDB table first before writing, there's a chance the table could have changed. Condition expressions can be used for the following write-based API operations. That's PutItem, UpdateItem, DeleteItem, and TransactWrite items. You cannot use condition expressions for batch write items. Now let's make sure that we understand how condition expressions work. I've kind of highlighted it in the previous slide, but it's better that we break it down right now. When a condition expression is used, we find an existing item with the same primary key, and we evaluate the condition expression against that matched item. If the condition is true, then the write will perform and will be done. Otherwise, you abort the write. So if we were going to update a user, which is one of the examples that we're going to do today, we first would find the user ID, because that would be the primary key. We're going to make sure that it exists. So we're going to assert that the user ID exists. If it's been found, then we will proceed and perform the write. Otherwise, we would abort the write, because we're not updating a user. We would end up creating a user in DynamoDB in that instance. So now that we understand what condition expressions are and how they work, let's do a few examples together. So the first thing we're going to do is create our table. We are going to create a table called users. And so I'm in my AWS console right now in the DynamoDB service, and I'm just going to create a new table. I'm going to call this table name users. The partition key is going to be PK. And then everything else is the default values. I don't want us to get into the minutia of setting up this table, because the point of this exercise is to learn about condition expressions. So I'm just going to hit create table. All right, our users table has been created. Let's now set up our example. For this example, I am using serverless framework to invoke all my local functions. So I actually created a new serverless project and used the HTTP API template to just initiate this project. You can just use AWS console and run your test functions there in Lambda. I just chose to do this in Visual Studio Code and using serverless framework because it is easier for me for running and testing these examples. I do have a tutorial to show you how to set it up, so feel free to check that out. But as for that, we're just going to walk through this. So right now, I have two functions that have already been created, our getUser and our createUser, and they're not using conditional expressions right now. GetUser is here for us to query our user table. We retrieve in a user ID, and then we're going to look for the user, look for that key, and we'll return the user's information or turn back 404 if it does not exist. The user ID is a path parameter, and that path parameter, actually, this is how serverless is helping here, as it sets up the functions. So I have the get user with our path set as user ID, and it's a get method. So you can see here, I also have our update user, create user, and delete user already defined so that we can test all these easily. This get user gets the path parameter has been sent in. It's going to then retrieve that user and return it back. I have defined a mock here that has the user ID. So if we run get user, right now our table is empty. So the user doesn't exist. So if we run serverless invoke local, and then we do the functions get user, and our mock is this get user JSON, this user ID doesn't exist. Okay? So run back this, and we receive a 404. The user doesn't exist. So now let's create a user. So we go down, and I have an example for create user. Right now, our user ID is just a UUID that gets generated. So we will generate a UUID. Primary key will be set up as a user with the hash and then the UUID that was generated. And then our other attributes, which is user ID, the first name, last name, and email. The first name, last name, and email are coming in from the body of this API request. So we do have another mock called create user, which passes in the first name, last name, and email. So if we run create user, we will successfully create user in our users table. And there is the user that we created, John Smith, with the email J Smith. Everything here is just the setup of our project. So now let's start talking about using a condition expression. So we need to update this user's information. So we're going to call an update user function. So now let's define update user. Now, update user and create user are going to look very similar because update user, it will have the body with the first name, last name, and email, and then the path parameter will be the user ID. So we're going to take our create user function here, and we will call this update user, and our user ID will be the path parameter. So that will actually be event, path parameters, and then the user ID. If we call this right now, and the user ID did not exist, we would not be updating. We'd actually be inserting a new item into our table. So right here, this is update user, and this user ID does not exist in our table. So go here. See, we only have one, and that user ID is 5E9, and the one that we have in our example starts with 74C. So this will instead insert Janet Smith. We call serverless invoke local with our update user path. It succeeds, but that's because it created a new item. That's not how we want update user to work. If the user ID doesn't exist, we want to abort. We want to throw an error instead, and we'll throw a 400 status code. So we do this by using the condition expression. So we go back to our handler here, and we're going to add in our parameters condition expression, and we want attribute exist. So in this case, it will only update that user if that user ID exists. So if I change this update user to be a C at the end, so it's a different user ID, if we run update user, we get 400. The condition request failed. It's errored out. And this is us logging the error. Go here, we have our params, we catch our error, and we're just logging this to the console. I'm going to remove that so our response that comes back is a little bit cleaner. If we then wanted to update, let's say, Janet Smith that we put in before, and let's say instead her email was janet.smith, now we are going to update her email address. So you see our status, return 200, it was successful. And if we go back to this record, and this is Janet Smith here, she has been updated to janetsmith@test.com. So now we know how to use a condition expression to check if an attribute exist. We can use this to check if an attribute doesn't exist. So if we went back to our create user, now generating a random UUID probably won't create a collision, but if something weird or wonky came along the way that maybe for some reason it generated all zeros, we want to prevent overwriting a user when we meant to create a user. So we can make the condition expression here, and we would do attribute underscore not exists, okay. And this will prevent us from creating a user with creating a new user in the users table when there's already an existing user ID. There is another scenario here that we might want to handle. We have all these users and they have email addresses. And honestly, we probably want all our users to have a unique email address. So you might say, oh, I want to guarantee uniqueness on an email address. So I'll do condition expression not exist for the primary key and attribute not exist for email. So you might want to say attribute not exist but this will not work because what happens is that DynamoDB is going to first look for the key, right? If we go back to the flow chart that we showed initially, it looks for the primary key, then it determines if that condition is true, and if it's true, it writes, otherwise it doesn't write. In this case, it's only ever going to evaluate the email address for that record. And so this statement would fail. Like if we run it here, you see it says status code 200. And the reason why is because the primary key doesn't exist. And therefore the email doesn't exist. The record isn't there. So we're going to insert it even though they have the same email address. So see here, now we have John Smith with two different user IDs and the same email address. And that's because, again, like I said, it pulls back first the primary key, and the primary key doesn't exist, and therefore the email doesn't exist, and it inserts. Another thing with DynamoDB is that it cares about the performance of its writes. So it doesn't allow for unbounded items to be checked because DynamoDB puts a premium on predictable performance. So the same amount of time it takes to write into an empty table will be the same for it to write if it has terabytes of data in it. And that is because one of the biggest sources for unpredictable performance is unbounded queries. So if your database needs to validate against a number of records, as your data grows, this number of just email addresses that it has to evaluate off of, your conditional writes get slower and slower and slower. So to avoid this, DynamoDB doesn't allow you to assert conditions against unbounded number of items. Actually, in fact, it doesn't want you to make assertions against multiple items. So it's going to locate that single item and compare the conditional expression off of that single item. So how do we have a user table with unique email addresses then? We have to make two records for our user. We're going to have to make a record for the primary key on the user ID and then another one for the email. So this means that when we create a user, we're going to have to write with a transaction. So we're going to use TransactWrite. So what we are going to do is update our create user to do the TransactWrite call. So first we need to create the items that are going to be added into our transact call. So we'll have a const called TransactItems, which will equal an object that holds TransactItems. And this is an array of actions that need to be done. The thing about the TransactWrite is if one of these actions doesn't evaluate, one of the conditions doesn't evaluate as true, then the whole transaction gets aborted. So what we're going to be writing here is a put, and the first put is the put that we've already defined, and that's here. So we have a put with the table name. The item is going to be the item that we defined here. I'm going to just take this object, put it here. And then we have our condition expression. And in this case, our condition expression is making sure that our primary key does not exist. We don't need this anymore. The next transaction we're doing is that we are also going to add our email as a primary key. So this will be a put. We have our table name and our item. In this case, it's just a record that holds the primary key, and we'll define our primary key as email hash, and it will be the event body's email. And again, we can do the same condition expression. So this is the transact item. We're going to check to make sure that the user ID does not exist in the table, and then we want to insert this, but we also want to make sure that the email doesn't exist in the table, and we insert as well. So if we call this, we would change this to be transact items, and this will be TransactWrite. The rest of it is the same. If we make a call now to create user, first, this primary key doesn't exist yet, right? Because right now we've been writing them with only the user ID. So it's going to succeed the first time and write it. And the next time we call, it will fail because the email exists. Let's clean up our table first. We're going to get rid of all these records. And now let's test. So go here. I'm going to call serverless create user. And it was successful. Let's look at our table. And there is now for our user, it's going to have the two records. It will have the user ID and then the email. And this is how we're going to guarantee uniqueness. If we make this call again, it's going to fail. It's going to throw 400. See, our transaction was canceled because of the condition check failing, and it was failed on our email. So now we have guaranteed unique emails when a user is created. So now that we've written our create user, and we can see that it works successfully, let's start thinking about how delete user would work. Every time a user is created, they have two records. They have their unique email, and then they also have the user ID. So when we want to delete a user, we have to delete the unique email as well as that user item. So I'm going to take our create user and then modify this to be our delete user. So we're going to delete user, and we're actually using our path parameter. So I'm going to steal this from our update user. So do our delete user. This would do a delete action, and we would delete our user based off the user ID if the attribute exists. And then we actually also need the email. And if the email exists, we need to delete the user as well. Delete that record as well. So there's a couple ways that you could go about this. You could query the database for the email address. So you could get the item for the user and then use that email address that is returned to delete the email record. Or you could require the delete user to pass in the email address. For this example, we can just write our email, and we could retrieve this email from our get item. So I'm going to write that really quickly. So what I've updated this method with is that we're going to first get the user's email by doing a get. So we pass in the user ID, we get the email. When the data is returned, we will set the email variable, and then we will do our delete action. Delete the item that has the user ID, which holds the full record of the user, and then we delete the email record as well. And this will be a transaction that deletes both records. Now, obviously, there's a little bit of the risk. The user could change their email beforehand, and then we could have some lingering records. This is just one solution. There's other solutions that you can go with, and this is just one solution of many that you can choose to do. We went through the condition expressions that talk about an attribute existing and an attribute not existing. We can actually go a little bit further and use condition expressions to check for balances. So, for example, we could have a user that maybe has a certain amount of reward points, and we don't want to allow the reward points to go below 0. They can't go negative, so they utilize and spend that amount of reward points and nothing more. Let's do one more example illustrating that. So let's write a function that manages these user rewards. So I'm going to first define a user reward function, and it's going to have a path with the rewards, and we're going to make this a put. And then we're going to make our mock very quickly here, and this will take in an amount that we are updating. And this is not the most ideal way, but we're doing a really quick write. So let's just also have it pass in an operator, and this is how we'll know if we are adding or subtracting our user rewards. So in this case, if it's 100 plus, that means we're going to add 100 points to our user rewards. If it was a minus, we're going to subtract that amount. So now we're going to learn how to use our condition expression in order to validate more towards the business logic level. In the case for the update user rewards, if we are subtracting rewards, we don't want the user's rewards to go below 0. So we're going to have a condition expression that makes sure that the reward balance that we have for our users is going to be greater than or equal to 0 when the amount gets subtracted. So we are going to define the parameters for our DynamoDB update equals, set our table name to table name, and our key is primary key. We will set a condition expression. So let's right now think about this only if we're subtracting rewards. So we can write condition expression, and we're going to have a new attribute, and we're going to call it reward balance. When we call update onto the table and we find the primary key for user ID, we are going to have an attribute that's called reward balance. And if reward balance is greater than or equal to the amount that we are passing in, then we will do the remainder of these operations, which is we're going to update. We're going to actually write an update expression. So we're using update expression where we're explicitly calling to set a specific fields. So we're going to call set reward balance equal to, in this case, we're talking about subtracting. So we're going to say reward balance minus amount, colon amount. So I'm adding this colon amount because we now have an expression attribute, and we haven't set it yet. So we can use our expression attribute value, and we pass in a list of those values. And in this case, we have amount, colon amount, and this is going to be what we're passing in from our body. So event dot body dot amount. So this is going to handle our negative value. Let's finish this, and then we'll expand on this method to handle the positive scenario. So in order to do the remainder of this work, we're going to call DynamoDB update, pass in our params, our promise, then we will send back the status code of 200 if it's successful, and if it errors out, we'll send back a 400. So now we're just going to write a simple if else. So we're also going to say if our event.body.operator was equal to plus, and we'll do a certain event. Otherwise, we'll do this. Changing here, we can get rid of our condition expression. We can say plus, and right here we'll just say let params equal an empty object. So let's now test this. First, we're going to add a reward balance, and then we will subtract. Our update user rewards already set to add 100. Let's make sure to get the correct user ID, and also let's make sure this attribute exists. So we're just going to add a new attribute, call it reward balance, and at the moment we're going to make it be 0. So first let's add 100 to our reward balance, and that was successful. This was running this parameter, which is going to just be adding. It's not using our condition expression, it's just doing the update expression. So we go to here and we refresh. We have a reward balance of 100. And now let's update to make our reward balance error out. So at this point, what we're going to try to do is take away 200 points. So we're taking away 200 points. And that was a 400. So we drew a 400 exception because the conditional request failed. That condition expression that was saying if the reward balance was greater than or equal to our amount. So let's make sure to see that it works. Let's say, okay, we're not going to use 200 points. We're going to use 50 points. So the remainder should be 50. So we run this, get 200 as our status, which means it succeeded. And our reward balance has become 50. So there you have it. You learned about condition expressions in DynamoDB. And you've learned different ways of using condition expressions. You've learned how to check if an attribute exists, if an attribute doesn't exist, and you've also learned how to use it in more of the business logic rules. There are other ways to handle condition expressions, but this is a high-level overview, and I hope that you have enough to now go out and be more confident when using DynamoDB in your AWS solutions. If you liked what you saw, please subscribe to my channel so that you can get notifications for more videos like this. And if there's anything that you want to learn, feel free to leave a comment below. This tutorial was made because someone requested to learn about condition expressions in another video that I made. I am always paying attention to my comments, and I'm more than happy to make a short video on anything you want to learn about with AWS or other programming and computer science tips. Until next time, happy learning.